Hello all, welcome to Embedded Linux Learning Point, Linux from Scratch 11.1 episode 17. Okay, in this episode we start from the Gmp module or package. The last episode we finished building the benutils. Let's clean up the benutils. Okay, so the Gmp package contains math libraries. Okay, let's extract the Gmp. Then let's change directory to Gmp. Okay, they have useful functions for arbitrary precision arithmetic. Okay, installation of Gmp. Note, if you're building for 32-bit x86, but you have a CPU which is capable of running 64-bit code, and you have specified C flags in the environment, the configure script will attempt to configure for 64-bit and fail. Avoid this by invoking the configure command below abi32 config. But our system is x 64 64-bit architecture, so that's okay. The default setting of Gmp produce libraries optimized for host processor. If libraries suitable for processor less capable than the host CPU are desired, generic libraries can be created by running the following. If library suitable for processor less than the capabilities that the host CPU are desired, I think this is not in our case, at least what I will be running on a virtual machine with the same capabilities as the host. Then let's move to configure. The meaning of the new configuration options: enable CXX. This parameter enables C++ support. The docs dir, basically this is where uh, they specified the correct place for documentation. Compile the package and generate HTML documentation. The test suite for Gmp in this section is considered critical. Do not skip it under any circumstance. Okay. Caution: the code in Gmp is highly optimized for processor where it is built. Occasionally, the code that detects the processor misdefines the system capabilities, and there will be errors in the tests or other applications using the Gmp libraries with the message illegal instruction. In this case, Gmp should be reconfigured with option build x86-64 PC Linux GNU and rebuild. Okay, let's build it. Probably it'll take some time. Ensure that 117 tests in this case suit passed. Check the result by issuing the following command. Okay, anyways, we are going to run the test cases. By then we'll just see the contents of Gmp. Okay, the install libraries are libgmp.so and libgmp plus xx.so. This contains the precision math functions, and xx contains C++ precision math functions. Okay, now the build is done. Let's extract the generate the HTML documentation. Okay, and let's run the test suite. What does this TE does? So make check this syntax is basically to redirect the, both errors as well as the output to the basically the file, or we are just piping it to the Gmp check log. So let's understand what TE is doing the command in Linux. TE in Linux. Okay. The command in Linux with examples reads the standard input and writes it to both the standard output and one or more files. Okay, here basically if you want to store the logs, here we are storing the logs in the Gmp check log as well as redirecting it to the standard output, what we see here. In the next command we have awk. Let's see what the awk does. AWK is a utility that enables programmer to write tiny but effective programs in the form of statement-defined text patterns. Okay, it's basically, I think we have compiled AWK before. That's okay. Scans a line, a file line by line, and splits each input line into fields, compares input lines into fields, perform actions on matched patterns. Useful for transform data files, produce formatted reports, programming constructs, format output lines, arithmetic and string operations, conditionals, and loops. So AWK option, selection criteria or set of actions, input file, the output file. Here AWK, this is the action, and this is the output file. Options. In our this thing, we are not using any options. I feel it looks like that. Behavior of AWK. By default, AWK prints every line of data from the specified file. Okay. Print employee.txt. Okay. So probably what it is doing is it is checking, it's printing all the past tests, and okay, as it says 197 tests should be passed from this file. So end So it's pass, and it's a construct. I think it's a loop where we total the number of passed tests. It's interesting. And we install this. Let's install the HTML documentation. Okay. Next, we move on to MPFR. Then remove the Gmp module. Then we extract MPRF, MPF, MPFR, MPFR. Okay. CD to MPFR. Then the installation configure with this configuration options. The MPFR package contains functions for multiple precision math. Contents or this is the lib MPFR multiple precision math functions library. Okay. Now let's make it build with make. What is important here is under the hood in Linux, it has a lot of different packages. Okay, now the build is done. Let's HTML for installing the documentation. Okay, the test suite for MPR in this section is considered critical. Okay, let's run the tests. Okay, now we run the tests also. Looks like okay. Then we install the package. Well, it is installed. Plus we install the documentation also. Fine. Now let's clean up this rm-rf, not double r, not double hyphen. Then we mpfr, then tar. Okay, let's move to mpc module. Tar xvf, then cd mpc. The mpc contains a library for arithmetic of complex numbers with arbitrarily high precision and correct rounding of results. Okay, let's put it for configuration. Of course, in this phase of LFS, we act as kind of script, like just executing commands and checking the output. Meanwhile, we learn what these packages are doing. Nothing more. The contents of MPC contains complex math functions. One thing is we don't know how these things are used in the Linux world or in Linux, but I think we will. Yes, I will not run the test cases. Straight away I will install it. I will install the HTML also. So these packages are required for Linux, but I don't know where exactly they are used. But I think the the other modules or other applications would be using these packages, contents of this package. Then we will clean the PC stuff. Before that, go back. Then rm-rf mpc. Then let's move on to attr. Let's extract attr attribute. Attr package contains utilities to administer the extended attributes on file system objects. Okay, let's cd to attr, then configure it with these options. The contents are basically okay. Let's build it. Extend attributes on file system objects gets the extended attributes of file system objects, sets the extended attributes of file system objects, contains the library functions for manipulating extended attributes. Then make install. We install this package. Then let's move to ACL. Before that, come back and then clean the attribute directory. It's rm, not em. Then tar xvf acl, then cd to acl. Configure this package. The ACL package contains utilities to administer access control list which are used to define more fine-grained discretionary access rights for files and directories. Okay, let's build it. The ACL test needs to be run for file system that support access control after core utils has been built with the ACL libraries. If desired, run this package and run make check after core utils has been built later in this chapter. But I'm not going to do it now. That's fine. We'll delete it. So I'll install this. Now let's come back. Remove the ACL package content. Then tar xvf libcap cd libcap. The libcap package implements the user's specific interfaces to the POSIX 1003.le capabilities available in Linux kernel. These capabilities are partitioning of all the powerful root privileges into a set of distinct privileges. So prevent installation of libcap, prevent static libraries from being installed. Okay, and then compile the package. Lib is lib. This meaning of the make option. Lib is equal to lib. This parameter sets the library directory to user lib rather than user lib 64. Okay. Then install the package. Since I'm not going to run the tests, that's fine. The contents of libcap is cap sh, a shell wrapper to explore the constraints capability support. Getcap examines file capabilities. Getcaps displays the capabilities on the required processes. Setcap sets the file capabilities. These are the related libraries. Then come back here. Then remove the libcap. Then extract the tar shadow package. Then cd to shadow. Then the shadow package contains programs for handling passwords in a secure way. Okay. I think this is where whenever we store when we enter the password, I think it will be stored somewhere. I think it uses this utility. The installation of shadow. Note, if you would like to enforce the user of strong password, refer to this. Okay. For installing crack lib prior to build shadow, then add with crack to configure command below. Disable the installation of group programs and its man pages as core utils provide a better version. Also prevent the installation of manual pages that were already installed in section. Okay. We are removing the groups installation here. Find the man make. Basically, we are prevent the installation of manual utils which are already installed. Okay. Instead of using default crypto method, use the more secure SHA 512 SHA-512 method of password encryption, which also allows passwords longer than 8 characters. It is also necessary to change the obsolete where S4 mail location for user mailboxes that Shadow uses by default to the where mail. location used currently and get rid of bin and sbin from path, since they are simply symbolic links to their counterpart in user. Note: if bin or sbin are preferred to be left over path for some reason, modify the path in bash rc after LFS is built. So all the above, whatever it said here, it's done here. If you choose to build Shadow with crackglib support, run the following. Okay, I'm not doing this, so I am omitting. Prepare Shadow for configure. Shadow for compilation. So we configure it like this, meaning touch user bin password. Okay, we created a password file here. The user bin password needs to exist because this location is hard coded in some programs, and if it does not exist, the default location is not right. With group name max length equal to 32, the maximum user name is 32 characters. Make the maximum group name at the same time. Name as the same. Then we compile using make. Okay, let it build. Probably it will take, okay, it may not take much time. Okay, this package doesn't come with the test suite, so we would directly install them. Let's see the contents of Shadow. So it has a lot of different programs. Okay, first let's install it. Then install the man pages. Okay, now let's go to configuring the Shadow. This package contains utilities to add, modify, and delete users and groups, set and change their passwords, and perform other administrative tasks. For a full explanation of what password shadowing means, see the doc how to file within the unpacked source tree. If using shadow support, keep in mind that programs which need to verify passwords, display managers, FTP programs, and POP3 daemons, etc., must be shadow compliant. That is, they need to be able to work with shadowed password. To enable shadowed password, run the following command. To enable shadowed group password, okay, let's just go to just cat the doc how to. Let's just read a little bit if it is not that big. Okay, it is a big file. Okay, okay, okay. From where it starts. Okay, now the installation instructions in this document are somewhat out of date. Okay, Linux shadow password how to aims to describe how to obtain instant configure. Introduction. This is the Linux shadow password how to. This document describes why and how to add shadow password support. on a Linux system. Some examples of how to use some of the shadow suits feature is also included. That's fine. Let's not get into this. It'll take more time. But anyways, Shadow's default configuration for user add utility has a few caveats that need some explanation. First, the default action for the user add utility is to create the user and a group of the same name as the user. By default, the user ID, UID, and the group ID numbers will begin with 1000, 1000. This means if you don't pass parameters to user add, each user will be a member of a unique group on the system. If this behavior is undesirable, you will need to pass one of the G or N parameter to user add to change the setting of user group ENAB in etc login defs. See user add 8 for more information. Second, to change the default parameters, the file etc default user add needs to be created and tailored to suit your particular needs. Create with it. So we're going to make the IRP etc default and user add. We want to add a GID with 9. Okay. etc default user add parameter explanation. The group 999. This parameter sets the beginning of the group number used in the etc group file. The particular value 999 comes from -gid parameter above. You can modify it by anything you desire. Note that user add will never use UID or GID. It's a GID. If the number identified in this parameter is used, it will use the next available number. Note also that if you don't have a group with an ID equal to this number on your system, the first time you use user add without the G parameter, you will get a message displayed on the terminal. It says user add unknown GID 999. Although the account is correctly created, this is why we have created a group users with this group ID. Okay. Create mail spool yes. This parameter causes user add to create a mailbox file for the newly created user. User add will make the group ownership of this file to the mail group with 0660 permissions. If you would prefer that these mailbox fields are not correctly created by user add, issue the following command. Okay, no harm in adding. Okay. Setting the root password. Choose a password for user root and set. Change the password for root. Enter and the new password minimum 5 characters. Okay. Okay. What it says. weak password, enter it again to use it anyway. Okay, anyways, the password is changed. Okay, got it. No problem. The contents of shadow. Okay, we'll see. Since this is very, this is something which we need to know. The short description: CHG user to change the maximum number of days between the obligatory password changes. CHFN used to change user's full name and other information. CHG password used to update a group passwords in batch mode. Okay, this is group password. CH password used to update user password in batch mode. CHSH used to change user's default login shell. Expiry checks and enforces the current password expiration policy. Fail log is used to examine the log of login failures to set a maximum number of failures before an account is blocked or to reset the failure count. Get gets sub IDs. It's used to list the subordinate ID changes for a user. The password is used to add and delete members and administrators to group add to create a group with given name. Group delete deletes the group. Group mems allows user to administer his and her own group membership list without requirement of the super user privilege. Group mode modify the given group's name or GID. GRP CK verifies the integrity of a group file, etc group and etc shadow. Group con creates or updates the shadow group of file from the normal group file. Group uncon updates the etc group file from etc shadow and then deletes the later. Last log reports the most recent login of all the users of a given user. Login is used by the system to let user sign on. Log out D is a daemon used to enforce restrictions on logon time ports. New GID map, it's used to set the GID mapping of a user namespace. New group is used to change the current GID during login session. New ID map set the UID mapping of a user namespace. New users is used to create or update an entire series of user accounts. No login displays a message that an account is not available. It is designed to be used as a default shell for accounts that have been disabled. Password is used to change the password for a user or a group account. PWCK verifies the integrity of the password files. PWCon creates or updates the shadow password file from the normal password file. PWOnCov updates etc password from etc shadow and then deletes later. SG executes a given command while the user's GID is set to that of a given group. SU runs shell with suitable user and group IDs. User add creates a new user with the given name or updates the default new user information. User DL deletes the given user account. User mode ls is used to modify the given user login name, user identification UID, shell initial group home directory, etc. VHR edits the etc group or etc shadow files. VIPW edits the etc password or etc shadow files. libsuid library for process subroutines ID changes for users. Okay, now that We have built the shadow. The next from okay, that's all for this episode. In the next episode, we will build the GCC, which is going to take a lot of time with tests. So, in the interest of time of this episode, I'll conclude uh, with the shadow package, which is very important for user management, user administration. Anyways, thanks for watching. Please leave a comment in the comment section and the feedback in the same. Thanks for watching.